Hello, everybody. Welcome to Automating Success. I am your host, as you know, Joe Langton. Today I have Michael Santora. Did I say that right? Right on the
Yep.
show. Um, Michael is going to probably do a better job introducing himself than I would. I have to tell the people listening, I had a little snafu today. I had a late flight, showed up late. Michael has already been the best guest ever because he was willing to let us start 30 minutes later. So first I'll start with an apology. Second, I'll go with a thank you. And then I'll say, go ahead and introduce yourself now.
All right. Well, thank you. I'm glad to be on the show. My name is Michael Santora. I'm the CEO of Logic. And Logic is a logistics automation platform, so both hardware and software, focused on automating warehouse and transportation processes in the middle mile. So between ocean freight and manufacturing and last mile delivery, that's where we're focused, all of the space in between. And what's unique about our offering is we have the only multi-facility robotic system that integrates both the warehouse activities and the transportation activities.
That's amazing. So everybody that gets started with something like this, like has to be a reason. So, tell me more about your journey. I guess we'll just get right into it in founding Crown Holdings and establishing that Logic. Like, what inspired you to say we need to automate this area?
Really, experiencing warehouse operations from the real estate side. So my background is architecture and real estate development. I've had an architecture practice in New York City since 2008, and I've had a real estate development company also in New York City since 2012. And amongst other things, our design and development got into warehouse and industrial facilities. And I think the first thing I noticed being in a space where square footage is at a premium was the amount of loss. And when I say loss, I mean space that can't be used for what the purpose of the building is, more like circulation and support things that you need, but isn't the primary function. The amount of loss that exists in warehouse spaces. So if you take an apartment building, maybe 20% of your floor area is stairs and hallways and elevators, and the other 80% is apartments. You go to a warehouse, it's almost the inverse, where up to 70% of the space is open circulation area for forklifts to get around and staging and other activities. And only about 30% of the actual floor space is the storage of goods. So I wanted to find a way to change those numbers, to increase the density of the usable space in the warehouse and decrease the amount of circulation needed. And the big culprit there was the forklifts. The forklifts, amongst other things, are challenging for businesses in many ways. I learned that businesses that operate forklifts have higher workers' compensation insurance rates for their employees because they're dangerous to be around. Actually, in some states, it's even higher than construction, which was a surprise to me. But we also designed these warehouses so that we can accommodate a forklift going down every aisle. And if we have multiple levels, we need a bigger forklift to go up higher levels and pull pallets out and bring them down for loading on trucks. I learned how long it takes to load a truck with a forklift. In some cases, that could be 2 hours, pallet by pallet, in and out of a truck. And that's a lot of downtime for drivers. So the motivation was, if I can get rid of the forklifts and move things another way, we can redesign the whole warehouse and we can make it smaller. And if we make it smaller, these warehouses can then be located in more optimal places based on where the goods have to go. So I live in New York City, and the port of Newark is probably 5 miles away from me. But when goods come out of the port of Newark, we take them to South Jersey or Pennsylvania to take them out of a container, put them back on another truck, and drive them all the way back here where the majority of the people who are receiving those goods live. So if we could take one of those warehouses in Pennsylvania and put it in Brooklyn, we would serve a lot more people with a lot less trucking, and they'd get their goods faster, and it would be cheaper, and we'd have a lot less pollution and all these other benefits. The challenge has been the way these warehouses are designed, no one can figure out how we can take a smaller industrial space in a denser urban area and make it do what these larger facilities in rural areas do. So that, that was what created the challenge of how do we solve this problem?
So I have to tell you, so first of all, you brought up workman's comp, and it is amazing. I talk to people about this all the time. People always want to know what their ROI is with automation. One of the things I talk about is, well, first let's talk about how much money you'll probably save in insurance, right? So I think it's great that you brought that up right out of the gate, because workman's comp is a huge cost that no one ever thinks about. Um, but we've all seen videos of social media of forklift drivers sometimes not even getting an accident on the forklift. It's hitting the racking, and then the racking falls on the forklift, right? So you have that issue. So, as you were talking and you were kind of undressing what it is that you're doing, I can't help but think, okay, so how are you doing that differently? So can you explain what the hardware side? Because you said right in the beginning, you use hardware and software to solve your problem. So explain to us a little bit about the hardware. Like, what does your hardware do, or how does it look differently? You could audibly explain it.
Well, the hardware is basically a robotic shipping pallet. So it looks just like a pallet, except it's plastic and metal instead of wood. It's got wheels, motors, and a battery in it. It has weight sensors. It's able to carry the same load as standard shipping pallets. So we match that. They're the same size dimensionally. So we have a 48 by 40, we have a 36 by 36. So all the other standard sizes. What we do differently is we've offboarded some of the individual control systems that exist on mobile robots today and replace it with our software that lives in the cloud and on a central node within the facility. And that replacement allows us to make the robots less expensive and more robust. So they can do more and they cost less because they're relying on a parent system that is doing a lot of the work that these other robots do individually. And the reason why we did that and why we invented this software control system specifically for this use was to bring the cost down so we can get to mass automation. When you have a few robots in a warehouse, it kind of acts like you do in a manual warehouse with forklifts. You still need the aisles, you still need the circulation. There's still other activities going on where you can't really change the format of the building. But when everything moves, when you get the cost of the automation down to a price lower than what labor rates are, and you can make everything move, the entire function of the warehouse changes. The size of the storage area, the way you unload and unload your workflows. So, and those changes then create a domino effect of positive improvements of how that warehouse operates, from less cost to safety to faster processing to less environmental impact.
Yeah, so it's fascinating to me because, it always amazes me with automation that it doesn't make a difference what industry you're automating. There's always these certain parallels. It's the same challenge that exists in both. Is if you don't get to the proper scale, you still are interacting with human beings, and you still have to do all those same things, and then you have to train the workforce to be able to deal with it. So I think that totally makes sense to me, anyways, with what you said, with bringing the cost down so they can scale it more. So you keep bringing up decreasing circulation, right? And I think, just for the people listening that maybe don't understand, some people hear circulation and think airflow, but I just want to make sure that the people listening understand it's about getting the products around the warehouse and what it takes, and probably backswing of a forklift and the amount of space it takes to move these pallets around. So I'm assuming, because you actually have automated the actual pallet, it's almost like you have a cube. So you probably need a lot less space in the aisles to get it to where it needs to go. Am I seeing this right?
Yeah, I mean, in fact, we don't even need the aisles. So they're all just clustered together in storage with just a few empties. What our system does, we've combined warehouse management and automation control. So let's say we're at the cutoff of your warehouse today. All orders are in, and this is everything that we're going to process tomorrow. We're not accepting any new orders. What the cloud system does is it processes how we would move the pallets, and everything is on one of our moving pallets in this scenario, around the warehouse most effectively to accomplish those tasks. And then we calculate all the different permutations of how that can go wrong if something doesn't arrive when it's supposed to arrive, or a robot breaks down or whatever, and come up with backup plans that our system then executes. So when you think about a storage area in a warehouse today, it looks a lot like a Home Depot. Big wide aisles, tall racks, goods stacked up to it, and you need space to go get it. Now we're just going to be individual roboticized pallets on the floor with the items in it. Together, those pallets will use a third of the space for the same amount of items as the current layout. And some of them, of course, are going to be blocked in by other robots. However, the system has figured out the order in which to execute the tasks. So it's optimizing the storage while the warehouse is down. So overnight, we've got this dense storage area with a few empties that shuffles around so that the robot we need first is in the front of the line, and the robot we need last is in the back of the line, and everything else is in between. And if something goes wrong, we can recover and make changes. We do have some empties in there so that we can continue to optimize as the day goes. If everything goes as planned, things are just going to come out in order and go back in order for the next day. So having things landlocked behind other robots is actually okay. And that's where the space savings really comes in the storage side of the warehouse.
All right. So visual or audibly, you've painted a visual picture for me of how they move around. How do they lift? Right. That's the thing I'm still wondering. So because you brought up in the beginning that you can change, there's space that's lift that's changed. Like, you're not using the height. The forklift can only lift a certain level. So I'm assuming you've also solved the problem to get them to fill the top void, or because you're utilizing these different buildings, you're not stacking as high. So explain that a little bit for people listening.
It's a little bit of both. So we design our own lifting system. Imagine an elevator with no walls that aligns to pallet racking. So we worked with some of the biggest pallet racking manufacturers in the country to design modifications to standard pallet racking that will allow our robots to drive into it. So if you've ever seen an automated storage and retrieval system, which is like a pallet shuttle that is built into pallet racking that's meant to pull goods from deep storage in the back out to the front so a forklift can access them. We kind of work like that when we're in racking, except our robot's untethered, so we can come out of the racking and drive around the floor and do other things in the warehouse. So we haven't come to a scenario yet where we needed to go multi-level because we already tripled the density on a single level. So if you have 3 levels of racking in 10,000 square feet, we would fit the same amount on a single level in the same 10,000 square feet. So most cases we wouldn't have to. When we do have to, or when there's a situation that we do want to use the verticality of a space, we have a lift. We drive in, it's just a flat platform attached to the pallet racking. It drives up to the second level, sends us a signal when it's aligned, and our robot drives off into that level. So we never have to lift it with a forklift. We just collaborate with a lifting mechanism that lines it up to the upper level that we want to reach. And that can work even if it's a multi-level building. So it doesn't have to be pallet racking. We can use this to go floor to floor. So a lot of people are thinking about repurposing office buildings and things like that. That
Oh,
are right
I
now.
was just gonna say that because with everybody's downsizing, with after COVID, you have all these office buildings that are looking for things to do, and now it can change into this space as long as zoning. So I mean, how do I guess zoning would be the only thing, but I'm sure people could work around that better than a vacant building not getting used at all.
Absolutely. And a lot of cities have really learned from those rezoning models, what they did with commercial and industrial, like New York City, for example. Lower Manhattan, Wall Street used to be all commercial. Now they made it partial residential, and it's grown into a much more vibrant neighborhood. And they've also have reasonably determined that light industrial uses like warehousing is appropriate to have residential mixed in to create live work communities for people that are operating those facilities. So I actually think that these type of uses are going to open up more in these urban environments as cities kind of learn to get the benefits of mixed use developments and mixed use neighborhoods, and also scramble to repurpose some of this vacant real estate we have.
Yeah, no, that's great, and it kind of shows your background. It's always great because it's like you can see a lot of people that I'm seeing that are successful in the automation space right now are people that they can kind of pull from their past or even current still backgrounds, kind of have this like hub spoke type thought process where it's like, yeah, there's going to be this space that's going to come available that's going to need repurposing. How are we going to we repurpose it? I think it's great. It's quite exciting to hear about it. So, um,
And before we jump off this subject, just I want to talk a little bit about the front of the warehouse quickly, because we
yeah,
talked about how we shrink the back, the storage area, and we're talking about maybe repurposing some old shopping malls or defunct office buildings into logistics. The question that would be on my mind if I was listening to this is, what about the loading docks? You're not going to put 40 loading docks in an office building now and have trucks backing up into the street and all that stuff. Well, because of our technology and because of the technology we were able to offboard from the physical hardware, we're the only company that allows our robots to go on and off vehicles. So we automate loading and unloading. Right now, if you have any automation system, doesn't matter what it is in your warehouse, that automation system lives and dies in that facility. And when you get done with whatever that automation system can do, you're still taking your stuff off of that, putting it on a standard pallet, picking it up with a forklift, and loading it onto a truck so it can go somewhere else, right? The warehouse has no purpose if there's not a vehicle taking something out of it or bringing something into it. So that has to happen. And that loading process takes like 2 hours with a forklift, one pallet at a time. That's downtime for truckers that are sitting there at the dock waiting for things to go in them. But that also is driving the requirement for having 40, 50 loading docks per warehouse. We load and unload in 10 minutes or less. So now that the throughput of the loading dock increases by so much, we can get 12 times the amount of trucks at a loading dock. We actually need less loading docks. So now we've got a small back of the warehouse because of the condensed storage and a small front of the warehouse because of the reduced amount of loading docks. And that opens up the opportunity to repurpose some of this other real estate that couldn't handle the loading dock setup that you would see at some of these larger logistics facilities.
so how do you reclaim these and how do you keep them in circulation? So it's like if the pallet is the robot and then that goes on the truck, how do you hold it responsible if that pallet comes back to you? And because right? So how do you deal with that?
It's, the system is not for every use. There are people out there that are shipping one-off pallets to smaller users and they would never get it back. But there's a lot of people out there that are moving through more than one facility that they can control from, a point to a point. And our system tracks all of our pallets. They have GPS, so we know where they are on the road. And our system also does automatic load balancing. So it's looking at today and looking at tomorrow and a week out and figuring out how to make sure each facility has as many pallets as it needs to execute that. But it does have to be, we do have to have an agreement between parties if it's working with multiple parties, or an understanding with the single party that these things do need to go back. And our pallets stack up empty, just like regular pallets. So for every 8 truckloads out, we get 1 truckload on the backhaul. So if you take a large 3PL as an example, they've got a central sorting facility like FedEx has in Memphis. And from that central sorting facility, they are going to palletize goods and put it onto a tractor trailer. That tractor trailer is going to cross dock at maybe 2 or 3 locations based on the distance the driver can go and the routing and all that other stuff. Cross docking is completely automated for us. So cross docking, when I say cross docking, I mean we're switching pallet loads from truck to truck, but not touching the pallet load itself. So those facilities are completely peopless in our operation. Truck drives in, the pallet drives off. It either puts itself in storage if the outbound truck isn't available, or drives right onto the outbound truck and keeps going. When it gets to the end of the line, a deconsolidation facility, and we're taking goods, palletized goods off the tractor trailer and manually depalletizing them into a local delivery van or one of those trucks with the shelves on the back that you see driving around your neighborhood, that's kind of the end of the cycle. And then we go back, we have a stacker that is kind of like the lift I described, just going up a shorter level, stacks up the empties, and one truck goes back to the beginning of the line and replenishes that first facility. So that's an example of a workflow that would work for that. Now, The technology is very versatile. So there's plenty of operations that we're working with right now where they're just using this as a low cost shuttle within the facility and it never has to leave. So we have the potential to take on all of that, but we could certainly service customers that just need pallet shuttling around a single facility and not dealing with inbound and outbound because of their other practices.
Yeah, I didn't even think about the shuttling. I mean, some of these facilities are so large and they just need to get it from point A to point B. That's another amazing use. The so you said that it's not for everybody. So I mean, I don't know if you can say who you work with or not. I don't know if you have any NDAs with them, but basically for someone that's not into shipping, like I don't, this is not what I do, like you do. So how do you go out and I mean, how do you acquire the customer in the first place? Right. So I mean, you had the idea, right? But then how do you go to market with it? Like once you had the idea, how did you start figuring out who was your actual prime target customer?
Well, I mean, we're fortunate that we've got a pretty large network in the real estate side here that was in the industrial space and was able to connect us with end users that we knew would use this. So we've been working with these companies to map their workflows and apply them to our system. So we show them demos of how their system's going to work in our demo facility in Boston, and then we implement there. And then we also have a great company, Abco, out of New Jersey. That's a systems integrator and warehouse supplier that's been representing us and bringing us into a number of different users. So they've got a huge Rolodex of people that can use our tech. And once they saw it, they got it. And they've been bringing us a lot of opportunities. So like I said, that the system is malleable enough that you can make it what you need it to be. If we understand your workflow, we can figure out a way to apply. So it actually is for everyone. The multi-facility is not for everyone based on their operations. But if you move goods on pallets, I guarantee you we can do it faster, cheaper, and in less space than you do it now.
Yeah, I mean, the whole time we're talking, I, I mean, I work with a company called Site One Landscape Supply now with my automation, and I can't help but to think, even for them, I mean, that's they move stuff around all the time, and it's like I feel like I need to forward them this podcast just so they can see it because I've been in their warehouses, and it's crazy to see it. If you just for people listening, like if you've ever been in one, I mean, there is so much forklift traffic, and there's trucks coming on and off, and I mean, even customs, like, there's these customs warehouses and stuff comes from overseas and it's got to come off and get inspected and then go to a different thing. So, I mean, do you guys do anything with that
Well,
stuff?
I mean, we're actually doing some work with them right now. It's funny that you bought them up, but you nailed it. If a container gets flagged for inspection with customs, first it goes through a giant X-ray scanner. If it needs to be opened, they need to take it to a facility within the port. Can't leave the port, obviously, because that defeats the purpose. They open
Yep.
the container up. The container's floor loaded, which means it's not palletized. Boxes are just stacked fully in it. And someone has to manually take all those items out, put them on a pallet, pick them up with a forklift, take them to a designated inspection area, let customs do their inspection, and then pack them back up and reverse it into the container, put it back the way it was and send it on its way. Right. So in our operation with them, we eliminate everything but the person physically taking the boxes out of the container and putting it on our robot rather than putting it on the pallet. But what it really does for them is increases the density of storage for them and the amount of containers they can process at a time. If the facility gets busy, and there's nowhere to grow in these facilities because they're at the port and they're constrained by other operations there, what happens? You just get pushed further back in the queue. So if you're an LTL shipment, meaning you're sharing a container with someone else, and that person's item gets flagged for an inspection and you're in there, and this facility is very busy, you could be waiting weeks or months for that container to be released until they do their inspection. Now, by tripling their capacity, it actually increases their throughput so they can get containers through the inspection process faster than ever. And it gives them the ability to grow where they are, which is paramount because, again, if these are located outside of the port, that is counterintuitive to the controls that they want to have by having it at the port. There are items there that never make it past the port. They get shipped back to wherever they came from. if they don't pass inspection. So of course, that to have that ability, you want to be located there and not have it come out into some other place.
Yeah, well, I mean, I tell you, the reason I went there and asked the question is I'm an importer, so I import robotic ball washing equipment from the UK, and they put it all on a container without a pallet, and it got to the DHL customs warehouse in Atlanta, and they were like, they called me and said, "Hey, if you don't come and get this unloaded within one day, it's all going back to the UK, right?" So now we're scrambling. Actually, they gave me 3 days. Had to get it all off. And as you're telling me this now, I'm thinking, man, I'm going to continue to import these, and they're gonna get, so like, now here's my next question. So they're going to get loaded at one location in the UK, and then they're going to come from the UK. They're going to go to the shipping warehouse, okay, to customs. They're going to get approved, and then from that point, they're going to go to my final destination. If I were to say, okay, I'm going to work with you because this makes total sense to me, how would that not, would I not even be someone you could work with because it's not enough? Or if I could, how do we pay? Do I have to buy the pallet? Is the pallet like a robot as a service where I'm just paying like a subscription or monthly for it? Like explain that like strategy, how you work with people.
So because of the amount of technology we were able to take off of the robots become leasable, which is very favorable to both sides. So you can lease one of our pallet shuttles for $200 a month. And that's
Wow.
substantially lower than what other companies charge for mobile robots because we don't have that cost in there. And the robot has a secondary life behind it. It's kind of like a car, right? If you get a $100,000 car and you lease it for $1,000 a month for 36 months, that's 36,000. How does the company pay for that car? Well, that car is going to do other things after you're done with it. They're going to lease it again, or they're going to sell it or something like that. So our robots actually behave more like a vehicle. Yes, there is going to be some refurbishment after a period of use, but it's going to have a secondary life. Other robots today function more like your cell phone, where after a couple of years, you basically recycle it and you need a new cell phone because the technology within it expires. The majority of our technology is in the control system in the warehouse, not on the robot. So the robot body gets to last a lot longer, and it opens up new financing mechanisms. And that was a big key for us because not everybody has a massive CapEx budget to go out and buy or finance a bunch of automation to then pay themselves back over time by reducing their operational costs through manual labor. We are set up to fit as an operating expense where you're reducing costs and adding robots little by little, because most of our customers are in a warehouse that's going to have to keep going through the transition, right? So we're set up to go into the warehouse in small pieces over a fixed schedule till we get to the point of full automation, which allows you to proportionally reduce your costs on the manual side as you increase this without having to come up with a major investment dollars.
Yeah. No, I mean, well, and I even think about like, so now you're talking about the releasing and reusing later on, like, and you can tell me if I'm way off the mark here, or maybe this is like an idea you already have, but okay. So going back to my ball wash system, those come in and now they're going to sit in a warehouse, right? And I'm sure $200 a month, nobody wants it to just sit on that pallet for a year or whatever, right? But because some of that, for me, the turn right, it won't be as fast as probably people you're working with. But on the flip side, then when that does finally get ordered, it shows up on a pallet, then it ships to the golf course I work at. Then from the golf course I work at, I have to get it out to the driving range. And logistically for me, that's always my nightmare because they don't necessarily have a forklift. So now I have to rent a forklift. And then that forklift sits there till I get there. And I'm hearing what your system does, and I wonder if there'll ever be a place for this, is it's like, if I were to use a company like yours from the start, it goes to a warehouse, I order it, it goes out to the site. Is there any way that pallet can drive it from point A to final destination, and when it's empty, that pallet just goes right back to get reloaded again, and the whole process repeats?
That's
Like,
exactly.
is that in the pipeline, or you already do that?
Oh, that's exactly what we're built to do. I mean, we don't operate the trucking. So you would have to coordinate the backhaul of that, meaning when you get to the end of your supply chain and you have a bunch of empty logic pallets, you're going to have to get a truck to bring it back to the beginning facility so they can be reloaded. But that's what it's meant to do. So some of the features that we have when we're in a facility, we're operating off of a digital twin of that facility. That's how we're able to control this. We're basically playing a video game of the warehouse in our system. And that node that's playing the video game is then telling the physical pairs of the virtual robots exactly what to do based on what we do in the simulation. Now, if you end up with in a situation where you go somewhere that we aren't mapped and we're not controlling through that digital twin, we have a remote control mode for the robot. So if you get to a golf course and you need to drive it around a golf course, now we're not built to go on grass and dunes and stuff like that. More
Oh,
warehouse.
it'd be on a cart path. I mean, mostly, I mean, these golf courses, you'd be amazed. I mean,
Yeah, put that
all
aside.
concrete.
If
Yeah.
you had a sidewalk, because we drive our robots down the sidewalk in Boston, you could see us like we were based at a university back when we started with our NSF grant, and we used to drive it around campus and everything like that, which you wouldn't see anyone else doing with their mobile robots. But we can get there, and we wouldn't have to map the golf course. You would just drive it like a remote control car at that point,
Yeah.
and you wouldn't need
So,
the lift or any of that other stuff.
so I mean, as you're talking about this, I'm just thinking like there have to be people listening to the show right now being like, I have to see this. So, like, do you guys have like YouTube videos? Is there a way people that
Oh
are
yeah.
listening? Is there like a link people can go to if you want to say right now? Because I mean, I'm literally, if I wasn't doing the show right now, I'd be looking it up. So,
So our website is www.logic-os.com. So like Logic operating system, and you can see
yep,
everything there. We do have YouTube videos, and they are up on the site. I don't remember the URLs for that, and they're probably complicated. And of course, if anyone's in the Northeast or anywhere, you can come to our facility in Boston and see them live.
awesome. So you're basically in the Northeast right now. So, what are your? I mean, I would assume there's nothing keeping you from not going, national or international with this. So, like, I mean, is it just a matter of just getting out? Like, how are you going to do that? How would you become national just from the Northeast?
I mean, we're already talking to companies all over the country. So um, the system went live the end of last year, fall of last year. We got it working in our facility. Tim Draper, the legendary VC, backed us, and his money went straight into our first fleet. So we partnered with Neotech, which is one of the largest contract manufacturers in the country, and they are our builder of these robots. So we have the ability to scale up rapidly, and we're actually setting ourselves up for mass production now in the production of our first fleet. That first fleet has become our demo facility, or it's operating our demo facility in Boston. And we've got a few more behind that are going to be in live operation with our first beta partners. So those will be going in this fall. We have so much demand right now that we actually had to shut the pipeline down, because we're talking about a scale of automation that no one's ever seen before. No one's ever seen 5 or 10,000 robots in a warehouse, but that's what we're going for. And that's what we're able to achieve based on the price point that we've hit for the automation. And that's what it would take to fully automate some of these larger facilities. However, we want to be cautious in how we roll out into that, because this is a new endeavor and a new product. We're not worried about having the customers for it. There's nobody out there doing multi-facility robots, and there's no one out there servicing the middle mile. So we kind of stand alone here, and we're really excited to get out, but we want to be really smart on how we do it to make sure that our customers get the best service from us, and that the quality is maintained through the growth.
Yeah. So it's funny that you say how you're not worried about a lack of customers, because that's the thing. There are so many people that could use this. I totally agree. Explain the middle mile thing. So I always tell people I'm the last mile of automation, because I am actually the guy putting them out. So, in the current shipping, for people that don't understand shipping, myself included, what is middle mile considered? I mean, last mile, I would assume, is FedEx brings you a package and puts it on your front
Yeah.
porch. Last mile.
Last mile
You
for
know,
me is a warehouse fulfilling a retail store. So like a Costco warehouse sending goods to the local Costco store, or an Amazon delivery from the Amazon warehouse to your house. The first mile to me is things like raw materials and manufacturing and ocean freight. And the middle mile is everything in between. So from the time that an item arrives at, let's say, the port of Long Beach, where a lot of the goods in the United States come in, that item has to go through customs inspection. It then has to go through a decontainerization process. They got to take it out of the container. They have to palletize it. Then it's going to go for its long haul shipping, which could be palletized, could be in container. So you may see a container on the back of a chassis of a trailer truck. You may see a container on a freight train going across the
Yeah,
country.
intermodal. Yep.
Yeah. Or you may see palletized goods, long haul, similar tractor trailers. Rail doesn't really play much in the palletized goods right now. But going from large facility to large facility and cross-docking facility to cross-docking facility to the point where they open up the cases. So imagine we're getting a shipment of Crest toothbrushes. The last mile is when I'm going to open up a box of 100 toothbrushes and put it into a bin that a Kiva robot in an Amazon warehouse would drive around to pick individual items. But all of that transit from the point of manufacture to the point where they unbox the case is the middle mile. And there are a ton of different activities in there. And the majority of those activities involve moving the goods on a pallet because they're at the bulk level where that's the most efficient way to get them on and off trucks and around a warehouse. And that's what we're replacing.
Awesome. And I'm glad I asked the question so people can understand. So one of the things that we saw was when we were doing some research was there's a bunch that comes up about dark warehouses. And I just want to know, like, if you can explain this concept of a dark warehouse, and its significance in the modern supply chain currently.
Well, the term dark warehouse just came from if no one had to work in the warehouse, we wouldn't need lights. So it'd be
Okay.
dark, right? Because
So
robots.
is bluntly easy is okay. So yeah,
So
but
that's
yeah,
where it's
but
from. Now, I don't know that we're ever going to have, well, we certainly will in the future have warehouses with absolutely no one in it. In our system, there still would be management level people, so it wouldn't be completely dark, but there is a substantial savings on what you need for the space for the workers, like conditioning the space. People working in Arizona in the summer need air conditioning in their warehouse, or they'd never be able to move things around in there. In our case, you wouldn't need to air condition that space. So the management people would have temperature controlled in the area that they're in, but the bulk of the warehouse wouldn't be. So not only do we shrink the warehouse size and the requirements that way, but by getting the people out of there, there are other energy uses that we don't need to have anymore, which makes the whole system much more efficient.
a warehouse wants to do this. How long does it take you to get everything set up? Like, I mean, right? Because I mean, it's not like it. I just can't imagine somebody just orders the robotic pallets and they're ready to go. Like, how does
Uh,
that setup work?
3 months is our lead time for the initial setup. And then the rollout plan is something that we kind of work out alongside them. But typically, we can continue to produce at the rate that they want to implement. So, assuming that this is not a greenfield situation where we're preparing to automate a brand new warehouse that's in construction, it's a brownfield where the warehouse has to operate. Our pace of production typically outpaces the time frame in which they want to automate based on when they can change over um, on current operations. So, but from an initial order, we're in your space in 3 months. So within that 3 months, we're going to take your space. We're going to create a digital twin of it. We're going to then look at different workflows within our digital twin. So we're going to be showing you a video of our system playing a video game of your warehouse in different ways to show you how we would operate it once we get to that level of automation and how we'll operate in the interim as we build up to that level of automation. Concurrently, we're producing the robots. So once we have the map set up and we're all in agreement on the workflow that we're going to implement over the different stages, the first set of robots are ready for calibration and first activity. And then from that point, the add-on gets easier and easier because we will set up the entire warehouse for automation at the onset. and only operate the parts that we have robots for, and then add those robots in as they come off the line and as the customer is ready to continue the automation rollout.
So this digital twin thing is like one of the coolest things that now that we kind of just stumbled upon in the show here, or I stumbled upon, you didn't stumble upon it, you did it. So, did somebody from your site have to go out and do that, or how do you make that digital twin? Do they just send you what the warehouse looks like? Is it photos? Is it a blueprint? Because I that fascinates me because I would have expected it to take way longer to get a warehouse up and running. And the fact that you guys can do that just in a few months is just fascinating to me. So, A, how long did that concept take for you guys to come up with? And then B, how do you make that digital twin?
Well, the concept of a digital twin has been around for a while, and it's something that I've used on the architecture side for a while, but we use it for monitoring the life of equipment. So imagine just taking highly detailed still images of a piece of air conditioning equipment over a period of time and watching where it fails and degrades for predictive maintenance, and understanding why something may degrade faster than it was supposed to or perform better than it was supposed to based on the use. So you're really just taking images and sensor data, putting it together and trying to figure out how that system behaved over its lifespan so that you can better project how you will treat future systems. We've inversed that. So instead of using it as a way to collect data, we use it as a way to transfer data, meaning instead of a robot having to figure out where it has to go all by itself, it can figure out what it needs to do in the digital twin, which is computationally less expensive than having it done individually. It's basically acting as a central brain for many robots. So the digital twin is like the queen bee, and we've got a bunch of worker bees instead of having a bunch of just independent robots.
Yeah. Yeah, no, that's thanks for the explanation. That totally makes sense now. So you said the cost of the actual robot, how you lease it through, but is all of that work covered in each pallet, or is there another, like, how do you guys monetize that? Because that seems to me is just somebody hearing about this for the first time. All of the background design work, that seems like the real kind of, I don't know how to put it, but this totally intellectual, like, I'm just kind of blown away how you guys do that. But is that just part of the service, or is that two
Oh yeah,
separate
that's
things?
part of the service. We come out and map it out, and it's not that hard. I mean, we can map an entire warehouse with 2 guys in a day. And what they're doing is they're using sophisticated LiDAR scanners and cameras in combination. It's some of these things you actually wear on your body. So it sits on your shoulders, and there's a like a round piece that sits above your head that scans in every single direction simultaneously. And you just walk the space. And there are several softwares out there that take all of those LiDAR scans and images and piece it together to a view that you can move around, just like how you can move down a street in Google Street View. And once
Okay.
we have that model, that's what creates the digital twin. And that's how we know what we can navigate through and how we get around spaces and all that. So it's vital, but it's not as complicated to get, thanks to a lot of new technologies that exist in scanning today, and then post processing of those scans into usable digital spaces.
How long did it take you guys to get all this put together? Because there's a lot of moving parts here. I mean, you keep saying really easy, 2 guys in a day, but it's only really easy because you guys did a really good job
Yeah,
planning
I
it out in
mean,
the first place. So
about 3 years of software development to take those scans and turn it into a virtual control environment. So there was a tremendous effort done by a team of superstars that got us to this point that makes this part of it very easy. And that was important to us, that in 3 months, we scanned your space, we built a digital twin, we designed a workflow and showed it to you, and you've accepted it and approved it. And your first fleet of robots have already been produced, and we can produce them quickly because we designed them to be simple and be built fast. And we're ready to go. And I think that's a fresh concept because most companies in this world, from what I understand, have a much longer sales cycle. And it's like 6 months to a year before some of these companies actually get up and running from the time that they talk. And we're seeing that companies are ready for automation now and they want to move quickly. It's no longer a luxury. It is the labor rates in this market can't support the business operations, or the business operations can't support the labor rates in this market, or we just can't find the people to do it because there's a shortage of people that want to do these jobs. So,
Can't find the people that can actually get. I mean, there's so much more to this. And I don't want to go too deep into this because I don't want to piss anybody off when I say it. But I can tell you personally, for me, what's causing me to automate my book of business is I can't even get people to pass drug tests anymore. Right? I mean, there's a lot going on in the world that makes people want automation, and a lot of it is people seeing it more and more, so they just are starting to believe in it. But yeah, I've seen that curve too, and I will say your sell rate, your uh, how long it's taking you is great. I mean, even in me selling automation, sometimes it's a 6 month to 1 year cycle, and I'm just cutting grass. I mean, at the end of the day, it amazes me how quick you're doing it, but I will credit you. I have to applaud you guys for this because I think that you're making it so easy for the end user by just being, in and out a couple of days. That's what we do. Just that in itself, like if I had a warehouse and I wanted to automate, I'd be like, dude, that's all it's going to take. You're making it seem so easy. It's really hard to say no. And it's probably unravels so quickly, they can't even come up with an objection.
and I think the real key here is that because we were able to lower the hardware costs enough, we can actually add white glove service into the package and still be less expensive than everyone else. And that's what people want. Like one of the other unique things about us is we track inventory through weight. So all of our robots have weight sensors in it. And the weight sensors are so sophisticated that we can actually find items in a 3D stack from a 2D platform while they're on the robot so that we can automatically cycle count. You know what cycle counting is? When someone has to go
No,
through the
I don't. Go
warehouse.
ahead.
All right. So if you're not confident in your warehouse management system's inventory, you send someone through the warehouse with a clipboard or an Excel sheet or whatever to count all of your stuff and make sure that it actually is what it is. With the weight based system, we know when something moves and we know when nothing moves. So if we have a pallet with 50 items that weigh 1 pound each on it, and all of a sudden that weight goes to 49, we know we're missing an item. So we can direct the cycle counting only to the place where we see a problem rather than just, looking at everything in the warehouse to see if there is even a problem. So
You're blowing my mind, man. But see, that's awesome.
huge
Yeah.
time savings. But the other thing that we're doing with it is we're using it to identify products by the known parameters of the product itself. So this is a surprise to people who get warehouse management systems for the first time. They're like, great, I'm getting a warehouse management system. All my inventory is going to be in here and everything is going to be plug and play. That is not the case. Getting a warehouse management system is like getting a blank Excel sheet and expecting a financial model. You could make a
Mhm.
financial model, but you got to input all the factors, right? Same thing with the warehouse management system. You now have to input the data on all of your items. And to no surprise, some people don't do it properly because maybe they don't understand the system, maybe they're lazy, you name it. Or they do it great from the beginning and then they let it taper off. We don't let that happen. Part of the white glove service we have is that we enter your inventory into our item master and we keep control of it. This way, when you take a box of Listerine mouthwash and put it on a pallet, but it was supposed to be Crest toothpaste, we can say, hey, we can sense the perimeter of this box and the weight of this box, and we know that's not the right item. It also allows us to build mixed pallets optimally. So in a last mile situation where CVS is fulfilling one of their retail stores, they're going to put a bunch of different items on a pallet that's going out to it, or whatever conveyance they're taking, right? And that's not easy to do. Building a single item pallet, 50 boxes of the same thing, that's easy. Try stacking 50 boxes of 50 different things. Well, you have to make sure that the levels or the stacks and rows are level so you don't have oddball crooked things. You have to make sure that the heaviest item with the strongest box is on the bottom, not putting it on top so you don't smash the item below it. Our system figures all that out because all that data is input by us. So when I tell you to build a mixed pallet of 20 items, we already know what goes at the bottom and what goes at the top. We're actually pulling the robots out of storage to the interaction area where someone is taking the items from one robot to another in the order in which they need to be stacked. Where today, it's all tacit knowledge, meaning the person runs around the warehouse and is stacking as they go and restacking based on what they grab to make that optimal stack and doing the best they can. This is figured out before and built into the order in which the robots move around. But
Yeah, the software is actually controlling the process based on how it delivers it.
yep, and
That-
we're controlling the inventory in a shareable item master. So, if I ship golf balls and you ship, Titleist golf ball 3-packs, we can share that information. It's not proprietary and no one really cares that someone else has it. It's just known accurate information that we push down to every one of our customers. And if Titleist now makes golf balls in a 4-pack and you start ordering 4-packs, we're going to get that data pushed down to you so that you always have that.
So how much does your robot weigh? Like as you've been talking, I'm thinking about the normal weight of a pallet versus your system. Does that ever come into a factor in trucking?
It could. Right now it doesn't. So the robot weighs about 120 pounds. So it is heavier than a standard pallet. Most of that is the battery. Batteries are
Yep.
super heavy. And there's no getting around that. But most people that would use our system, at least on the commercial goods side, put other limitations on as to how heavy and how high you can stack a pallet for safety reasons within the facility. And those limitations come in below the roadway limitation of the vehicle. So there is a delta in there where our weight doesn't really matter. Maybe we're using an incremental amount of more fuel on the truck because it's pulling a slightly heavier load, but we're not at the point where it's like, the truck holds 26 pallets, but you can only put 18 on because of the weight of the robot.
Well, and you don't have the weight of a forklift pulling in and out of the truck the whole time. So I mean, I mean, you're not pulling the forklift, but on the flip side, you're straining the suspension on and off and back and forth. So yeah, I mean, it's like,
Yep.
it seems negligible to me. But how do you charge the battery? So you brought up the weight of the battery. How is it charging itself, or how do those keep charged?
We have chargers in the warehouse. They connect to standard 120 volt power, so outlet power, and it's 2 guides. The robot drives into it and rollers funnel it in, and then there's a magnetic charger on the back end of it, and it just connects and charges. The robot will charge itself in about 45 minutes, and that 45 minutes will last 7 days for average use time. And the robot charging cycles are built into our management system. So the same system that's pulling a robot out of storage so you can pick an item off of it is also sending it to a charger when it needs a charge. And that can happen after it goes below a certain threshold. So let's say it gets to 15%, it knows it needs to stop for a charge on the way back. In non-24-hour warehouses, we're still 24 hours. So in the middle of the night, robots are going to be going back and forth to the charger, filling themselves up for the next day. And that's how we minimize the amount of charging infrastructure, because we expect a robot to be on a charger at all times. Meaning, not that the robot needs to be on a charger at all times, that the charger has a robot on it at all times.
Yes. So instead of charging 500 at once, they're just taking gulps as they need it. So you might only be charging 10 at the same time, but they're not doing it all once. So this is exactly, so now you're really speaking my language, because this is why I'm such a proponent of outdoor automation versus that people buying electric zero turns, right? So I'm going to use this just for most people listening. There's a lot of people that are in my space that listen. So this is the same thing that I say. If you get a bunch of electric zero turns, you bring them all back at the same time to your shop and you charge them overnight. Versus when you have a bunch of electric robots out, they charge themselves as they need it in a constant cycle. It puts way less strain on the infrastructure. And I always like to bring this up on the show because there are people that want to bash any electric charging. Oh, it's not any better. But when you tie automation into electric, it is a completely different outcome because you're sharing You're decreasing the load and you're spreading it out, right?
Absolutely. And if we get, once we get into urban environments, like we can always add more chargers to have robots charge within a certain window. So I would say the best we can do is one charger per 40 robots. However, look at markets like New York, where there are variable rates with electricity based on peak times of day. If we said, charge my entire fleet between 2 a.m. and 6 a.m. because I can pay a lower kilowatt hour rate during that time, we can add a few more chargers to make sure all the robots get charged during that window. So you can really help balance out the overall system with our system. And that's just, a parameter that we can add into the software. We can limit charging times. Right now, if you get the system, we call it opportunity charging. When there's an opportunity to charge and we need to charge, we charge. So we're always ready. But if you want to limit that so that it's done in a certain period and it saves money or saves energy, that's an easy program for us.
So this might seem like a dumb question, but knowing that you're in the Northeast, and as today, I'm calling you from Illinois, or we're talking from Illinois. Has there ever been a thought, especially since develop a real estate background, to for a guy like myself to buy an empty warehouse, equip it right out of the gate with your system, and turns into just like a hub, like an in between space? Is that something that you guys are working on, or is that something that's even an opportunity for somebody to be like, hey, I'm going to buy a space, find a place that is getting rezoned or whatever, and just equip it with their system right out of the gate and kind of be that through point? Is that something that
I that is a vision that I want everyone in industrial real estate to see. So it's not something that we're pursuing on our own because we're really focused on the robot side, but I encourage everybody who is in industrial real estate today to start thinking about what the future of industrial real estate is. And the future industrial real estate isn't some 4-acre facility 100 miles away from Chicago. It's an industrial building that's probably vacant that everyone overlooked, just outside of the loop, that can service everybody. And with our robots, that all becomes possible, right? So someone who has real foresight in the real estate world is going to start gobbling up some of these overlooked industrial sites and treating it like a furnished apartment, right? You move into an apartment and it's got all your furniture in it. Well, now you can move into a warehouse and it has all your labor in it in the form of a robot.
Yeah. Well, I mean, I'm literally thinking like, man, like if I had the money to start buying those places, I mean, same thing. I'm focused on this part too, but I hear this and I'm like, this is a huge opportunity because goods don't just sometimes they don't just stay on a truck. I mean, I know even for the robots I buy, you got to have warehouses all over. They don't get off the truck; it sits there till somebody else orders it. And I'm just looking at it like, man, all these manufacturers I work with, they could be using this without question. I mean, we're already doing pallet sharing. Like when I get tractors shipped to me, because I also sell tractors, they come on a pallet. I have to wait for 8 for them to come pick them up. With your guys' stuff, this is amazing. I have to tell you, you never know who you're going to get on a show, and like the stuff they're going to do. But your system has such real world benefits. Like right now, it's like right now there's a huge benefit. I'm so excited for you guys. Like seriously, you guys are a rocket shit, man. Like seriously. So before I get into just some questions about you, because I always like the listeners to kind of learn about the person that was on the show just personally. Uh, I do want to give you an opportunity to talk about that team of superstars that you had. So, how many people are in your operation right now doing this with you?
There's only 10 of us. And, we were able to put this system together by using a lot of existing technologies. So we do rely on some external engineers and developers that have specialties in areas that we needed or created a product like a drive system or wheel or something like that we didn't have to come out and create on our own. So we were able to fast track some of the development by using existing technologies in new ways in conjunction with other existing technologies to form our robots. So our team is more high level and we've got some specialists, but the beauty of it is it's all made in America. So Everything that's on the robot is from somewhere in the U.S. And we're very thankful that we're able to do that based on our technology and not having to uh, use some of the things that you can only get reasonably priced by going overseas. So we've got a lot of small businesses, primarily in the Northeast, but also elsewhere in the country that are participating in here that have made really meaningful contributions and really have been so inspired by the technology that they go above and beyond by taking their existing stuff and tailoring it to us. I mean, mostly because they see the scale that we're going to reach, and they're going to be a major supplier for us as if we continue on with them. So we're very thankful for all their support and getting the different components that made this possible together.
Well, and I mean, so you brought up your P, your investor and everything, but I mean, what is it? I mean, do you guys see yourself going being publicly traded one day, or do you see yourself being profitable enough to just stay private? Like, I mean, what are your guys' thoughts, or have you even not have you gotten to that point yet, or are you just kind of going out and seeing where the universe
Yeah,
takes
I
you?
mean that I'm gonna kind of let it play itself out. Right now, our focus is just getting into more opportunities in the market to really test the ability of the system and validate everything that we don't know up until this point. So we're in a great place right now, but there are certainly going to be challenges ahead as we enter different market situations. Um, but we're confident that we can resolve whatever those challenges are because they're just technical challenges, and any technology company goes through that. But we'll see where we end up. Like I said, we're at a point now where I'm turning people down and telling them that they're going to have to wait until next year because our pipeline is already full for 2024. So we've got a really, really good outlook on how things are going to go for us, and I think it's really going to be our option as to how we finance this going forward. But we've designed the business plan for the company to sustain immediately out of the gates. Now, there are other technologies that we want to develop that support this, so the mobile robot doesn't do everything in a warehouse. And we've got some other ideas. So I think, the future of the company from that perspective is really relying on, when we want to roll those other things out. We, I don't think we could have expected the tremendous response we've been getting for just the mobile robot. We earlier on, I was saying we're going to feel that kind of growth when we complete the whole system because we have a picking arm lined up and we have our own transport vehicle lined up that kind of automates this whole system. Now we're seeing that we're going to be bigger than we ever thought we were going to be with just the mobile robot alone, and that kind of changes how we finance the other developments. So we still want to do those other developments because we know the supply chain needs them, and it really completes the fully automated vision that we have. But there's certainly much more opportunity now for us based on the response we've been getting from phase one here.
Yes, awesome. Well, good for you guys. So we've hit the part of the show where I always like to. I mean, you're a very articulate, passionate guy, much like myself. I feel like. Tell me about the younger version of you. I mean, it's like I always feel I'm just from my own personal experience when I was a kid on the playground hanging out with my friends. Never did I think this is where I'd be right now, right? So, but it's always fascinating to me just kind of hear and let people talk about kind of what from the point you were a boy, your family background, and just kind of things you like to do outside of what we're talking about today. So yeah, so I mean, yeah, brothers and sisters, like kind of start from there for us.
Well, I'm an only child. I would say my hobbies are mostly social and skiing. So I love to travel and just be with people I like to be with and do fun things. And check off as many places in the world as possible. Uh, yeah, as a kid, I was always building things. I had my bedroom was like a Lego city, and
Uh-huh.
it's kind of evolved from there. So I don't know that I was going to be in robotics specifically back then, but I was always interested in building things and the connection between spaces and transportation and logistics. So I think that's where the passion for this really came from, is that, because I like to travel and because I travel a lot, I'm really attuned to the challenges in traveling. Like when I have to go, when I have to show up at an airport 2 hours before I leave, and I'm like, why can't I just show up 5 minutes before I leave, like a train station? Like stuff like that bothers me. And I think about how much better the world would be and how much better everyone's lives would be if we streamlined a lot of these processes, because at the end of the day, all we really have is time. So if we can optimize that and get some time back and spend it doing what we love doing instead of getting to what we love doing, everyone would live a better life. And I think that logistics is a great place to start with that, with streamlining and automating these processes, because as we streamline and automate this, the benefits that logic is going to release into the logistics ecosystem is then going to creep into these other ecosystems, right? Like we're long term, we're thinking about how we improve intermodal connectivity and how trains and trucks and ships work closer together and faster than they do today, so that we can provide a more streamlined system. And when you think about that, if we can make improvements there, that's kind of like the way we travel and move around. And think about how much time any of us spend on the road. I mean, we started late today because you had a travel delay. So, it
Yep.
affects our lives all the time on a daily level. And it's a problem that I've always been passionate about solving. I think logistics is the place that we want to start with it.
Yeah. So you said you travel a lot. Where's your favorite place you travel? Like,
Uh Man, I've been to so many good places. I love Mexico. I love Europe. Still exploring Asia. I need to get out there a little bit more, but I've found something amazing almost everywhere that I go, and I think it's just about experiencing the other cultures and the other environments, which is what I like the most. Like I love going to other places and seeing all of their buildings and riding their transit systems and trying all their food and all that. And it it's almost, I mean, I'll give Italy the win on the food, but everywhere else, there's always just been something amazing that I found that I love about the place. And you know, definitely revisited a lot of them multiple times because of that.
yeah, I mean, that's one of the things I like about the space too. I mean, even take the travel delays away. Same thing. I feel very blessed that I get to travel and see so many different places. And I'm kind of like you. I don't know that sometimes I can pick a favorite. I mean, the thing for me is I love the water. So anytime I'm any place with a coastline, that's going to be like right up there for me. But I'm always fascinated by when you go to these different places, how at the end of the day we're all human beings, but everybody has their own kind of culture and the way they see and approach the world and their different paces. And it is actually kind of cool to learn and see that, right? So that's why I asked the question if there's certain places that you just like better than others.
Yeah, I mean that's the best part, to go somewhere else and live like they're living as best you can and experience what life is like for them.
Yeah. Well, and that's the thing too, is that, in I think for people like us, I mean, I can just tell you love what you're doing, right? And for me, it's like, when you love what you're doing and you can travel and you can do all this different stuff, it's like you don't really feel like you work. You're just constantly learning. Like I always tell people, like I don't feel like I'm working. I just feel like I'm always learning. And learning can be fun. I feel like sometimes when I look at the way my life is now that I have a career, I sometimes wish our school system was that way. It's like if I could have learned from grade school till I graduated high school the way I seem to learn today, I feel like I would be even more intelligent. I don't know if you feel that same way too, but I
Oh,
just,
absolutely. I mean, I don't want to digress too much into the education system, because I definitely think there are some major improvements that need to happen there. But I'm a perfect example of this. I mean, I started this project just before COVID, and I'm an architect by training, and I'm running a successful architecture firm and real estate development practice. So I had a full plate. And I had this vision of how we were going to automate warehouses, but knew nothing about software or mechanical and electrical engineering as it pertains to designing robots. And when I set out to do this, I basically learned what I needed to know off the internet. Now, I'm not saying that I'm writing code and building parts or anything like that for the robot. I didn't get to that level, but I got to the level that I needed to get to understand who I needed that had the expertise to build this dream team that made it all work. And, that's just a testament to how easily we can re educate ourselves with the resources that we have today when you have the determination and interest to do it. And most people think changing careers is like, going back to school for 4 years and something like that. And it's really not. I mean, we can all do something different if we really wanted to, and the resources are out there. You just have to apply yourself and find it. And I think Logic is a great testament to that, because it came from someone that didn't have a background in anything that's really important to us right now.
Yeah. Well, in the sake of making sure I get you off for your hard stop, I don't know that I could have a better ending point than what you just said, because I think that the the fact that you were able to put this together and build this dream team of people and solve an apparent problem in a space is just really amazing. I think you're an amazing person. You've been an amazing guest on the show, and I just want to thank you for even taking the time and coming on the show. So.
Oh, and thank you for having me. I mean, it's forums like this that get the idea out into the world, and that's so important to us. And so grateful that you guys reached out, and it's such a great show with so many listeners. And I'm excited for how many people are going to hear this, and I'm sure we're going to be doing demonstrations for a number of your listeners, and couldn't be more thrilled about that.
Well, I certainly hope so. And I'm telling everybody that listened, you should definitely go check this out. And even if it's not a space you're in, make sure you tell anybody that could be interested in it. Because, at the end of the day, it's people like the people that listen to the show and people like us that are going to change the world as we currently know it. And there's a lot of greatness that can come, a lot of great careers that come from this space. So yeah, and hopefully future friendships. So I'm glad that I've met you, and hopefully one day in our travels we'll be able to go out and meet in person one day.
Oh,
And so
absolutely. Listen, I'm going to be up in Chicago moving golf automation equipment for you before you know it.
hey, that now I might hold you to that. That's great. Everybody, thanks for tuning in. I hope you love this episode as much as I loved producing it. And until next time, have a great one.